Good morning, everyone. So we are back to the class with another materials. Which we are going to talk today is the general definition of an angle. Okay. Okay. Yeah. So previously, why do we need this material? So previously we have talked about trigonometry, but all of them are in context of an acute triangle, a right angle triangle. So the angle shouldn't be more than 120, shouldn't be more than 90 degrees. Okay. So what about if we are given trigonometric ratios that are more than 90 degrees of an angle, right? So that's the question. Okay, so that's why we need the general definition of an angle, where you are going to learn about what happened if you got an acute angle, an obtuse angle, and so forth. Yeah. So yeah. So angle, as you know, is the maximum, yeah, zero. The maximum amount is 0 to 360 degree. Yes, 360 degrees the maximum, and 0 is the minimum amount. In a way, you can add more, so it means like it's going round and round and round, so it can multiply to 720, even to 1440, and so forth. Okay. Yeah, but then again, less than 90 degree, is acute, and then um, between 90 degree and 180 degree is obtuse, and then 100 to 360 degree is what we call as reflect angle. Yeah. Okay, so those are the three things about angle. Okay, so in general definition of an angle, you are learning about what we call as quadrant. Okay. Wait, let me use another color. Okay, yeah, so we use what we call as quadrant. Okay, so this is, at this point, is 90 degree, this is 0 degree, and then this is 180 degree, 270 degree, and then back at here is 360 degree. Okay, so we it's the same thing as the angle, the name of the angle that I have mentioned, but here in the quadrant we use the first quadrant. Okay, this is the first quadrant, this is the second quadrant, this is the third quadrant. Okay, this is the fourth quadrant. Okay, so the first quadrant is basically acute angle, and then the second quadrant is basically obtuse angle, and then the reflect angle is basically from the third and fourth quadrant. Okay. Alright, yeah. So the general definition of angle is basically trying to find the which angle are equal to the angle that is presented. Yeah. So for example, you can see the work example 5.3. 5.3 number A, it is 120 degree, right? So let me use this color. Okay. So okay, you always start from the 0 degree, yeah? So 0 degree and then to 120 degree. So for example, this is the, okay, so for example, this is number A. So this is, for example, 120 degree. Okay, so you start from the left, from the right hander, 120 degree, and then you are trying to find, in terms of acute angle, what is the 120 degree equal with. Okay, so that's what you're trying to find. You got 120 degree, which acute angle is equal to 120 degree. Okay, so what you do here is to say that 120 degree is equal to an acute angle of 60 degree. Okay, so in this case, the conclusion is 120 degree is equal to acute 60 degree. Okay, okay, so this is what's being said in the book. Okay, so I'm going to give you another a clearer way to do this. Okay, so the way you do this is basically use the horizontal line as a point of reference. Okay, so it's basically the same thing, but you convert 120 degree into 180 degree minus x. Okay, so as you know, 180 degree minus x is equal to 120, so x is equal to 60, right? So you convert 120 degree into 180 degree minus 60 degree. Okay, so basically it's just conversion. Okay, so now the general definition of the angle is 180 degree minus 60 degree. Okay, alright, you might ask, can you convert this with 90 degree? So for example, like, can we convert 120 degree with 90 degree plus 30 degree? Can we convert into that? Yes, you can convert into that, but it's going to be a little bit more complicated. So we stick with the 180 degree or 360 degree if the angle is reflex. Okay, so that's number A, right? Later I'll oh yeah, I forgot to share a couple of notes, so later I'll share those in Edmodo. Okay, so now let's try to do a couple of numbers, right? So number A, 120 degree, we convert that into 180 degree minus 60 degree. Okay, the next one is 430 degree. 430 degree, we subtract 360 first from 430, so we get 130 minus minus 60, so you'll get 70 degree. Okay, 70 degree is already an acute angle, so you can say like 360 degree plus 70 degree. Okay, again, use 180 or 360 as a point of reference. Okay, 3 pi divided by 4, so 3 pi divided by 4 is, wait a minute, times 180, so 45, so 135 degree. Okay, use 180 as a point of reference. Obviously 135 is less than 180, so it's minus 45 degree. Okay, And then the last one, minus 2 pi over 3 times 180 degree. Okay, so minus is it's clockwise. If it's plus, it's counterclockwise. But if it's minus, it's clockwise. I mean, so minus 2 times 60, so it's minus 120 degree. Okay, so you can say 360 degree minus 120 degree. Then you will get, because it's minus and it's acute, it's not yet acute, I mean, it's obtuse angle right now. So 360 minus 120 become 240 degree. 240 degree means 180 degree plus 60 degree. Okay, so, and as you can see, let's match what I have made here with the one that in the book. Okay, so A, 120 degree is anti-clockwise rotation, acute angle with x-axis 60 degree, right? So it's here. And then acute number B, acute angle made with x-axis 70 degree. Okay, so it's matched with what it's set in the book. Okay, and then acute angle made with x-axis P divided by 4. The minus and the plus doesn't affect the final answer. Okay, so 180 minus 45 is acute angle made with x-axis P over 4. P over 4 is 45. And then the last one, acute angle made with x-axis P over 3. Okay, in your book they are explained more towards visual, yeah, it is explained visually, but I'm trying to explain technically using calculation. Okay, and keep in mind the calculation should be in point of reference to 180 degree or 360 degree. Okay, so there's one question I am going to answer it first. Sir, yang D itu min 120 derajat, kenapa nggak dikurang sama 180 derajat? Yang D min 120. Karena min 120 itu kan ke counterclockwise kan, dia ke sini. Jadi yang pertama mesti dikurangin dulu itu 360 kurang 120. Jadi kita tahu sudut aslinya berapa. Baru abis itu dipakai point of reference dari 180 gitu. Karena dia minus kan? Karena dia minus. Jadi karena dia minus, dia clockwise. Oke, kita mesti tahu dulu sudut aslinya berapa. Dan using point of reference dari 180 baru kita oke. Ada lagi yang mau ditanya dulu sebelum kita lanjut? Okay, so in the second and the third quadrant, usually you are going to use 180 degree as the point of reference. Okay, karena because the angle is on that area. But if it's in the first and the fourth quadrant, you are going to use 360 as a point of reference. Okay, so let me give you another example. Let's say you have got 330 degree. Okay, 330 degree. So it is in fourth quadrant. So you use not 180 because 180 you are not going to get acute angle. Okay, so you have to use 360 to be able to get the acute angle that you are trying to find. So you use 360 degree as your point of reference. So 360 degree, to get 330 degree, you need to subtract 30 degree. Okay, so now you get that the general definition of the angle of 330 degree is 30 degree. Okay. Okay, yeah. So all of these are technical. Okay, very technical. If you need help with the technical, you can ask the question. You can ask any question now. If not, yeah, I'm going to continue. So hopefully to make this much more sense. Right, yeah. So let me continue first. Okay, so now we are on page 123. Okay, we are on page 123. Now we are talking about the ratios. Okay, back we are talking about the ratios. Okay, so this is, if you see this quadrant, then this quadrant actually represents um something like Cartesian diagram or such. Okay, where the x is here is x positive, this is x negative, this is x negative, this is y positive, and this is y negative. Okay, so let me move this first. Okay, okay, now I want you to pay attention to the activity on book explore 5.1. Okay, wait a minute, we have a question here. Sir, jadi intinya kita cari pengurangan atau penambahan angle yang hasilnya bakal sama kayak soalnya. Iya, betul. Poin referensinya adalah 180 derajat atau 360 derajat. Oke. Ya. Oke, ya. Yeah, but instead of what is being said on the book, you just find the acute angle. I actually like to use this because it's much easier. And then if for example you want to use 90° as a point of reference or 270° as a point of reference, it's going to be clearer than if you use only the acute angle. Okay. Okay, so I'm giving you like a lot of different materials here, so you just have to pick your tools. Okay, the aim of that is to give you more complete oversight of the material. While if I'm only giving you like the, okay, just use the 180°, don't use the 90°, then you're not going to have the big picture of the material. Okay, so bear with me. Okay, just follow the technicals, then I hope that you can understand it later. Okay, so all right, so now we are talking about the ratios, right? So the ratios here, so for example we have an acute angle of any number. Okay, so we have an acute angle, so let's say we call this alpha. Okay, so alpha alpha has of course it has a x. Okay, it has y, right? So in this case alpha, x and y, both x and y is positive, right? So sin alpha is this is r is the hypotenuse, so sin alpha is y divided by r, which both of them are positive, so sin alpha is positive. And then cos alpha is x divided by r, which both of them are positive, so cos alpha is positive. And tangent of alpha is positive divided by positive, which will be resulted in positive as well, right? Okay, so everything in quadrant number 1 is going to be positive. Okay, so the positive or the negative is not going to be affected with this. Okay, so for example like here 180° minus 45, so it's, for example later sin minus 45. It's not that is not the case. Okay, the general definition of an angle is going to give you what is the angle that you should calculate with. Okay, what angle you should use to calculate 135°. Okay, but the negative and positive will come out from here. Okay, so let's continue with this one. Okay, you're in the second quadrant. Okay, so the x is negative, right? So because it's on that way, and then the y is okay, so the y is positive, right? So here, for example, we call this beta. Okay, and then the r. So sin beta. Okay, you can continue the explore 5.1 along with me, yeah. Okay, so you can put your notes there as I'm doing this. Okay, sin beta is y divided by r, right? Y divided by r, y is positive, r positive, so it's positive. Okay, and then cos beta is minus x divided by r, because it's minus and r. Okay, so it's minus. And then tangent beta is positive and minus, positive divided by minus, so it's minus. Okay, so as you can see here, if you have any r is assumed to be positive. Okay, so next one in the third quadrant. Okay, so let's say we have this angle, then okay, so the y is negative, x is negative, r is assumed positive. Let's call this as theta. Yeah, theta. So sin theta is in the third quadrant. That's just a symbol. Okay, just keep remember that we now talking about the third quadrant. Okay, so sin theta is minus y divided by r. Okay, and then sin theta, cos theta. So sin theta minus y divided by r, it's minus. Cos theta is minus x divided by r, so it's minus as well. And then tangent theta minus divided by minus, it is plus. Okay, okay, last one. Let's say we have this angle. Okay, I am out of, yeah, so this is minus y, x is positive. So let's say this is omega. Okay, so sine of omega, yeah, basically omega is rounded like that. Yeah, omega is minus y divided by r, so the sine is negative. The cos of omega is x divided by r, so it's positive. The tangent of omega, it's basically sine divided by cosine, so it's negative. Okay, so now you can complete the table on Explore 5.1. Okay, wait, there. Okay, yeah. Okay, so you can copy the same graph, and then you can make things like this. Wait a minute. Okay, yeah, so in the first quadrant, sin, cos, and tangent are positive, all of them, right? And then in the second quadrant, sine are positive, cosine is negative, and then tangent is negative. In the third quadrant, sine is negative, cosine is negative, tangent is positive. And then the last one, sine is negative, cosine is positive, and then tangent is negative. Okay, yeah, so now I'm giving you the ultimate yeah, I'm giving you the ultimate example. Okay, so we have like 45 degree. Wait, let us let okay, let me use 30 degree. Okay, so 30 degree, and then 150 degree. Okay, this is on the first quadrant, this is on the second quadrant. That in the third quadrant we use 210 degree, and in the fourth quadrant we use 330 degree. Okay, using the same angle. And now you can use your calculator, because I have mentioned, right, to check whether if my answer is correct or not. Okay, right, yeah. So so the in the first quadrant, 30 degree, right, all of them are positive, right? So sine 30 is equal to a half, and then cos 30 is equal to a half and the root of 3, and then tangent of 30 will be 100 1 over 3 and the root of 3, right? So that's in the first quadrant. All of them are positive, right? Sine, cosine, and tangent, right? So this is what we get. Okay, now it's going to be a little bit different with 150 degree, because 150 degree we have to convert it into 180 degree minus 30 degree. So now we use the 30 degree, but sine so sine, this is 180 minus 30. Okay, and then cosine 180 minus 30, and then tangent 180 minus 30. We use the 180 minus 30 as the sign of the quadrant, which quadrant we are working on. Okay, so sine 180 minus 30, it means we are working on the second quadrant, and sine in the second quadrant is positive, so it's the same as sine 30, a half. Cosine 180 minus 30 in the second quadrant is negative, so it's minus half and the root of 3. And tangent is also a negative, so it's minus 1 over 3 and the root of 3. Okay, the same thing with the third quadrant. The third quadrant is 180 degree plus 30 degree. Okay, so sine 180 degree plus 30, cosine 180 plus 30, tangent 180 plus 30. Okay, in the third quadrant, sine is negative, so it's minus half. Cosine is minus half and the root of 3, and then the tangent minus, and the tangent is plus, so 1 over 3 and the root of 3. And the last one is 360 degree minus 30 degree. So sine 360 minus 30, cosine 360 minus 30, and then tangent 360 minus 30. So sine in the fourth quadrant is negative, I think, yeah. So minus half. Cosine is positive. Wait, am I right? Cosine x, oh yeah, x and r, yeah. So it's positive half and the root of 3, then tangent is 1 minus 1 over 3 and the root of 3. Okay, so those are the example that I want to show you. Okay, let me give you a little bit of an overview. Yeah, so let's say we are using the same angle, yeah, 150 degree. Okay, my earlier question was, can you use the 90 degree as a point of reference? Yes, you can. So 150 degree, you are using 90 degree as a point of reference plus 60 degree, right? Okay, so if you use this point of reference, so for example, sine of 90 degree and 90 degree plus 60 degree, when the trigonometry ratio meet 90 degree or 270 degree in this case, it's going to change into cosine of 60 degree. Okay, so that's what happens. That's why it's easier for you to use the 180 degree as a point of reference. If you use 90 degree, it's going to change. If you use, for example, tangent 90 degree plus 60 degree, it's going to be changed into cotangent of 60 degree, because it's in the second quadrant, so it's minus. If you use cosine 90, if it's being asked, yeah, plus 60 degree, so cosine is going to be changed into sine 60 degree. Okay. Okay, so cosine of 60 degree is a half, minus cotangent of 60 is okay, this is second quadrant as well, yeah, jadi minus. So minus cotangent is 1/3 and the root of 3 minus, and then this is also minus sin 6a, yeah, minus half and the root of 3. Okay, so this is using 90 degree as a point of reference is a little bit tricky, but it's another tool, so it's up to you which one is better for you. But yeah, my suggestion is it's better if you use 180 degree. You can check all of this, yeah, so you can check all of this in the calculator. Okay. Okay, yeah, so that's the end of the material. The next thing we are going to do is the plus point, and then I'm going to let you to throw any kind of angle to show you more example. Okay, so